17.6 is about the distance formula, which is derived from Pythagorean theorem. And so there's quite a few other things in that section you don't really need for this class, so I'm just going to cover the basics of that. There's two really good visuals to understanding Pythagorean's theorem, and so I gave you two links right there you can look at if you want to. It's kind of neat. Pythagorean's theorem, I'm sure you've heard of, or that you probably remember from high school. Pythagoras was a Greek philosopher who discovered that if you have a right triangle and you label the sides A, B, and C, he discovered that no matter what, if you took A and squared it, the length of side A, and you took the length of side B and you squared it, it would give you the long leg C squared. A and B, it doesn't really matter which one you call A and B, but C is very important. C is what's called the hypotenuse. It's always across from the 90 degree. And so C is always the long leg, the diagonal. So Pythagoras came up with this theory that this would work for all right triangles, and it does. So those two visuals show you that if you have, like let's say, you have a triangle that's 4 by 3, and you want to find what C is. The visuals show you that if you take the square of the length of the side, so we're going to call this side A and this B this time. And let me just show you. So the length of side B is 4 units long. If you take a square that's 4 by 4, the area to that is 16. And if you take the square of the height of the triangle, which you said was 3 units, so 3 by 3, the square of that is 9. So Pythagoras says if you take 3 squared and you add 4 squared, oops, then that should equal the square that comes off of the side C. And so 3 squared is 9 and 4 squared is 16. So that makes 25. So that means C squared must be 25. So the square that comes off of C must be 25. And the video does a better job of this, but if you put, that means that the area of this has to be 25. So that means it must be 5 squared. So that means that this leg must be 5. And if you put all the blues, all 9 blues in there, and then start filling the rest of it with the red, the 16 red pieces, you will find that they all fit in there. So the blue square and the red square fit in to make that square off the diagonal. So that's what his theorem is built on. So let's do a couple problems. So let's say you have a triangle that's a right triangle, and this theorem only works on right triangles. So let's say you have a triangle that's 10 by 7. Whoops, let's make the 7 the B. And let's say you're trying to find C. Then you should be able to use Pythagorean's theorem that A squared plus B squared equals C squared. So I'm going to go ahead and call this, remember it's only important which one you call C, so I'll call this one A and this one B, but I could do it the reverse way too. So that means that this is 7 squared plus 10 squared equals C squared. So that's 49 because it's 7 times 7. Plus 10 squared, which is 100 because it's 10 times 10. So 149 equals C squared. So if you want to know what times what makes 149, you can use the square root button on your calculator. Now some calculators you'll have to push the square root button first, and some you have to push after. You're just going to have to play with it. play with it with something like the square root of 9 is 3. So play with it and try and see how your calculator works. But then you could take the square of 149. And I don't have a perfect answer. I'm going to go ahead and round out to the nearest tenths. So 12.2. So it's about 12.2. Okay, so try another one. So here's a right triangle, and it's missing the hypotenuse, the C. So I'm going to go ahead and call this A and B. So I know that A squared plus B squared equals C squared. So 40 squared plus 9 squared equals C squared. So that's 1600 plus 81. That gives me 1681 equals C squared. So I know if I use the square root, which you'll use more of this in in the next math class that you have. You'll learn more about the radical. And let's see. The square root of 1681 is 41. Then I know that this side is 41. So let's try when A or B is missing. So let's say that one of your legs, A or B, is missing and you have C. Now remember, C is always the one across from the 90 degree. So on the final, sometimes the C you'll be solving for C, and sometimes you'll be solving for A or B. So again, Pythagorean's theorem, A squared plus B squared equals C squared. A squared plus 36 squared equals 45 squared. So 36 squared is 1296. And 45 squared is 2025. So now I can use my inverse operations to isolate the A squared. And I get A squared equals 729. And then I can take the square root of that to get 27. Okay, so I can always test it out too. That's what's nice about Pythagorean's theorem, is I can see if 27 squared plus 36 squared really does equal 45 squared. So 27 squared is 729 plus 36 squared is 1296, and 45 squared is 2025. So 1296 plus 729, yep, is 2025. So then I know that for sure that's a right triangle and that I did it right. So sometimes they'll give you A, B, and C, and they'll ask you, is this a right triangle? So of course triangles, all triangles have 3 sides, so you could have different numbers for A, B, and C and it be a triangle, but to be specifically a right triangle, it has to follow true for Pythagorean's theorem. So like on this one, sometimes they'll ask you, is this a right triangle or not? Obviously it's a triangle, but you won't know if it's perfectly has a right angle until you run it through Pythagorean's theorem. So Pythagorean's theorem is A squared plus B squared equals C squared. So 28 squared plus 96 squared. Remember, the longest side is C. So even if they just give you the numbers and they don't tell you A, B, or C, you'll always know that this one has to be C because it's the longest one. So 28 squared is 784. And 96 squared is 9,216, oops, 100 squared. And then 100 squared. And then you can add it together, and you could say yes, it's a right triangle. So one that wouldn't be a right triangle, like let's say I said A was 6, B was 12, and C was 15. You could test it out so 6 times 6 is 36 plus 144. 225, and you can see this is not going to work out. So then you get 180 equals 225. So this can definitely be a triangle, side lengths of a triangle, but it's not a right triangle. Okay, then Pythagorean theorem leads to the distance formula. So they start putting, you start looking at diagonals on a grid. So let me put grid paper up. So let's say you had this line that went diagonal across grid paper, and it asked you what is the distance from like point A to point B. Well, you can't just count boxes because these cut through boxes, and so that won't work. So what you have to do is you have to use your knowledge of Pythagorean's theorem to figure out the true distance. So Pythagorean's theorem, remember, it works on right triangles only. So I'm going to make my own right triangle. So I'm going to make a right triangle, and a right triangle will always make a perfect square on the bottom. It'll follow that perfect square, so only 2 turns. If I do that, then I can measure a straight line on grid paper. So like this one is 1, 2, 3. This one is 4 units long. And it's 1, 2, 3, 5 units wide. So think about it off of grid paper for a second. We just talked about Pythagorean's theorem and how you find C. So you can use a squared plus b squared equals c squared, and go 4 squared plus 5 squared equals c squared, and 16 plus 25 equals c squared, and 36 equals c squared, and you can get 6. So then you know that this is 6 units long. Okay, I could have also made a right triangle this way. It doesn't matter if you're lefty or righty on the right triangles. It would have come out with the same answer because you can see that this is up 1, 2, 3, 4, and this is over 5. So it won't matter which way you make your right triangle. So you try one. Okay, so here's one for you to try, so you can pause it if you want to and try it, or just walk through it with me. So because it's a diagonal, I can't count the boxes, so I'm going to make a right triangle out of it. I can see that this leg of the triangle is 3 units long, and this leg is 4 units long. So I can go 3 squared plus 4 squared equals c squared, and 9 plus 16 equals c squared, and 25 equals c squared, and then I get c equals 5. Okay, so when I'm going across a grid, if you think about, let me draw this on the next screen and we'll talk about it. So if I draw this again and I name the ordered pairs, like this one is back 5, down 1. And this ordered pair is back 2, down 5. When I am finding, let me change colors. When I'm finding that the legs of those triangles, when I'm finding this first, let me erase this one. When I'm finding this first vertical line, vertical is along the y-axis, and this right here is my y. And I can count the boxes and know that it's 4, but the graph's going to disappear pretty soon and they're not going to have you on graph paper. So then you have to know, how do you find a distance between 2 points? And that's where this lesson's going. How do you find a distance between 2 points if you're not given the grid or anything else? How can you use your algebra skills for that? Well, I know that the distance straight down is going to be the difference between the y's. So if you look at that, -1 take away 5. Whoops, hold on. That's a -5. There we go, negative. So let me change colors because that yellow is hard to see. So if I take the -1 and I take away the -5, I'll get 4. And that's how far it was. So what I just did right there is I went y minus y to get the leg, okay, that's vertical. Now if I want to talk about the leg that's horizontal, I want to talk about this leg, horizontal is across the x-axis. So if I use that same thinking and I take my x's, -5 take away -2, I get -3. And this is 3 units. I know you can't have a negative unit, so hold on, okay? So, but can you see that that's 3, whether it's positive or negative? So, you know, if I take it off the grid, you know, we take it off the grid and we say this is 4, and this is 3, and we start using Pythagorean's theorem and we go 4 squared plus 3 squared. Is it going to matter that it's a -3? No, because -3 squared makes +9. That's why I said just ignore that it's negative. So I could use just the points to figure out the A and B of Pythagorean theorem, and then I can continue to solve it. And then solve it all the way and find that it's 5. So let me take the grid off. So taking the grid off and just giving you some points. What if I had -1, 2, and 4, 10, and I didn't want you to use graph paper? They're going to require you to do it algebraically. Well, I know that this is my x and y, and this is my x, y, and I know that Pythagorean's theorem is a squared plus b squared equals c squared, and I just showed you that you can get a by subtracting your x's, or b, it doesn't matter which one you pick, and you can get the other one by subtracting your y's. So I can use that information and take my x's and my y's, let me color code them, and I can take -1, take away 4, and square it, and I can add that to 2 minus 4 and square it, and it should give me c squared. Whoops, that should be a 10. Erase. There we go. Take away 10. So this is -5 squared, which is going to give me 25. Plus, this is -8 squared, which is going to give me 64. Notice how it didn't matter that we had negative lengths, because you're going to square them anyway. And that makes 6, 7, 8, And then you can see that you would get the square root of 89. So C equals the square root of 89, which ends up being about 9.4, because it's not exact. It's 9.43398, blah, blah, blah. I'm not sure which form they're going to ask on the final, but I've asked, and when I get the response, then I'll let you guys know. So try another one. So here's another one. Here's one that comes out clean to a perfect square. 2 and negative 6. Okay, so you can pause it and try this one if you want. Okay, so this is my x and my y and my x and my y. So I'm going to take my x's first, and I'm going to subtract them and square it. Then I'm going to take my y's, and I'm going to subtract them and square it, and that's going to equal c squared. So 2 take away 2 squared plus negative 3 take away negative 6. That's where you have to be careful. Make sure that you are taking away. Okay, equals c squared. 2 minus 2 is 0, so 0 squared is 0. Negative 3 take away negative 6 is 3, and 3 squared is 9. So I get 9 equals c squared, and I take the square root, and I can see that c equals 3. Okay, and let me throw a fraction in there, just so you have a more difficult one. So one more problem. So here's a problem, just making it a little bit harder, throwing some fractions in there. They might throw decimals at you. So again, you have your x and your y's, and you're going to subtract your x's and square them. Subtract your y's and square them, because you're finding the distance between the 2 points. And that's going to equal c squared. So I have 1/2 take away 1 squared plus negative 3 take away 4 squared. Use your calculator. Half take away 1 is negative 1/2. And when you use your calculator, just a second, negative 7 squared. When you use your calculator and you're squaring a negative fraction, use parentheses around it. Otherwise, your calculator will see it as a negative 1 times 1/2 squared. So just make sure you toss parentheses around there, or that you manually do it, like negative 1/2 times negative 1/2. But if you're going to use a squared button, make sure you toss parentheses in there. So negative 1/2 times negative 1/2 is a positive 1/4. Negative 7 times negative 7 is a positive 49. And so now I have 49 and 1/4 equals c squared. So I'm going to take the square root of 49 and 1/4, so square root of 49.25, or you can put it in a fraction if you want to, into your calculator. And it does not come out nice and clean, but it's around 7.01, 7.02 if I round off to the nearest hundredths. And again, I will find out if you can leave it in radical form, or if you, radical form meaning leave it as a square root of 49 and 1/4, or if they want you using your calculator to turn it to decimal. And that's the end of 17.6. You don't need a lot of the other stuff that's in the text. That will come with your next math class.